In this video, we'll talk about another way of calculating the enthalpy of a reaction. This is section 5.6, and this is using standard enthalpies of formation to calculate the standard enthalpy of an entire reaction. Standard enthalpy of formation is a way of putting a quantity of enthalpy to a specific compound or element or molecule. The reason for this is we can't directly measure the enthalpy of an item because enthalpy is a change and involves a process. So the standard enthalpy of formation is, well, how much, putting a process to it, how much energy would it take to make that substance from its individual elements in their standard state conditions in the way that they're found in nature. So the standard state, or the standard enthalpy of formation of a element that's already in its standard state would be 0 because it's already in standard state. It doesn't take any energy to get there. Any other materials, we can look at the appendix to find those values. So the appendix 2 in your textbook, at the very end of your textbook, gives for inorganic substances and organic substances the standard enthalpy of formation, which is the first column here. And this is more or less in alphabetical order of the first element present. And we're looking at the standard enthalpy of formation. Don't worry about the second two columns, we're just looking at the first column for now. It's very important to look at the states of matter. If we look here at silver, silver is listed as silver solid and as an ion in aqueous solution, and they have different numbers. It's 0 for standard state silver solid because that's already an element in its standard state. But for aqueous ion, it has a value. So be very careful when you're looking at this table that you're looking at the correct state of matter and making sure you're getting the right numbers. So how do we put this all together to find the standard enthalpy formation for an entire reaction? So I'm given some chemical reaction, A plus B goes to C plus D sort of thing. The standard enthalpy formation, delta H, and a little degree there means standard state conditions, which is 1 atmosphere and 25 degrees Celsius, of a reaction, Rxn, is equal to, now this big funny symbol here is a uppercase sigma, that is the summation, meaning you're going to add everything that follows it. So the sum of N times the standard enthalpies of formation of your products minus the sum, add up, all M times the standard enthalpy of formation of your reactants, where N and M are your stoichiometric coefficients. So if you have 2 carbon dioxides in your balanced equation, then N for carbon dioxide would be 2. That just means multiplied by the stoichiometry. And then these values are just taken from the table. So add up the values for your products, add up the values for the reactants, and products minus reactants. Let's jump into an example problem for this real quick. So this is practice problem B for sample problem 5.8 in the chapter. It says, using the data from your appendix, calculate the standard enthalpy of formation, delta H Rxn, for the reaction 2SO, sulfur monoxide in the gas state, plus 2/3 O3, that's ozone in the gas state, yields 2SO3, or SO2 in the gas state. So here's our product, here's our reactants. First thing before you start anything else is let's go ahead and go to Appendix 2 and look up those values for SO gas, O3 gas, and SO2 gas. So going back to Appendix 2 and finding them in alphabetical order. By the way, this is inorganic substances. Inorganic substances are those that don't start with carbon and hydrogen. So if you have a molecule that starts with carbon and hydrogen, like CH4 or C2H something, then you're going to look at the organic substances, which is the second table in the appendix. Still in the appendix, it's just going to be in the second table, so you won't find organic molecules under the C's of the first table. Just keep on scrolling through the pages until you get to the organic substances, which are in a separate table. So go ahead and write these down. So now here are my standard enthalpies of formation taken from the appendix. Notice some of them are positive and some are negative. That just means that the positive ones consumed energy to be formed, while the negative ones released energy to be formed. So looking at my balanced equation, so my equation is to find the sum of the products minus the sum of the reactants. So here are my products. I have 2 molecules of SO2, so delta H standard for the reaction, will be the standard enthalpy of formation for SO2, and because there are two of them there, I'm going to multiply that by 2. So that's what that N means. You multiply by whatever stoichiometric coefficient there are. Now there's only one product for this particular reaction. The second part is to subtract the sum of those standard enthalpies of reaction reactants. So the first one is SO2, and there's a 2 in front, so I'm going to write 2 times the standard enthalpy of formation for SO. I should specify for the other one too, this is in the gas state. If there's more than one listed, make sure you're looking for the one with the right state. And I'm going to sum, so also add in that 2/3 standard enthalpy formation for the ozone in the gas state. At this point, all you have to do now is plug in your values. So multiply that by 2. 2 times standard enthalpy of formation of SO2. It's 2 for the SO. And 2/3 times the 142. So that's all there is to it. You just plug in the values from the appendix 2. Make sure you multiply by the coefficients for your balanced equation, and then the products minus the reactants. So plug this in your calculator. 2 times -296.4 minus, now if you calculate a lot, so you do parentheses, just use parentheses. Otherwise, make sure you calculate this separate because it's minus this entire sum here. And you should end up with -697.6, and these are all in kilojoules per mole. And that is how to find the enthalpy of a reaction using standard enthalpies of formation.